Heating effect of electric current. The current flowing through a metallic conductor causes the free-moving electrons to collide with the atoms and ions of the metal, leading to conversion of part of their kinetic energy into heat. This results in production of heat energy in a conductor due to the electric current flowing through it, and this phenomenon is known as the heating effect of the current. Joules Law. If I is the current passed through a conductor for time t, then Q equals to IT, and V be the potential difference across the two ends of a conductor of resistance R, then by Ohm's law, I equals to V upon R, or V equals to IR. As potential difference is the work done represented by W during flow of charge Q, then V is equal to work done upon charge. Work is given by potential difference multiplied by charge, or W equals to VQ. On replacing V with IR and Q with IT, W equals to IR multiplied by IT, or W equals to I square RT using Ohm's law, that equals to VIT. The current flowing through the conductor converts the work done, I square RT, into heat, which can be calculated as W equals to I square RT joule. The relation between joule and calorie is 4.18 joule equals to 1 calorie. Hence, heat produced in a conductor in terms of calories is given by H equals to I square RT upon 4.18 calories. Joules' law can be stated as the quantity of heat H generated in a conductor of resistance R when a current I flows through it for time t is directly proportional to 1. The square of the current, 2. The resistance of the conductor, and 3. The time for which the current flows. According to Ohm's law, we can write H equal to I square RT upon 4.18 calories. That equals to V square T upon R 4.18 calories, which is again equal to VIT upon 4.18 calories. Applications of heating effect of electric current. Although heating in an electric circuit increases the temperature of the components, altering their properties adversely, it also has many useful applications, such as when the tungsten filament with melting point 3380 degrees centigrade in an electric bulb becomes hot, it emits light. The bulbs are filled with chemically inactive gases like nitrogen and argon, which prevent oxidation of the filament, thus prolonging its life. An electric iron consists of a heavy metal block enclosing a coil of high resistance covered by mica sheets, which are bad conductors of electricity but good conductors of heat. When an electric current is passed through the coil, it gets heated and we can iron clothes with it. The mica sheets prevent the current from entering into the metal block, thus protecting the user from getting an electrical shock. The fuse used in electric circuits consists of a piece of wire made of an alloy with low melting point, for example, lead and tin. If a current larger than the specified limit flows through the circuit, the temperature of the fuse wire increases, causing melting of the wire, and thus the circuit breaks. The fuses used for domestic purposes are rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere, etc. Working of electric furnaces, soldering, cutting, drilling, welding, etc. are based on heating effect of electric current. In surgery, a fine heated platinum wire is used for precise cutting of tissues. Example: a geyser generates 3000 calories of heat when 2 ampere current passes through it for 15 seconds. Calculate the resistance of the geyser. Given heat generated equals to H equals to 3000 calories, current equals to I equals to 2 amperes, time equals to T equals to 15 seconds. Resistance R is to be calculated. Formula: H equals to I square RT upon 4.18. Calculation: putting the values in the formula, we get 3000 equals to 2 multiplied by 2 multiplied by R multiplied by 15 upon 4.18, or R equals to 3000 multiplied by 4.18 upon 2 multiplied by 2 into 15. Therefore, R equals to 209 ohm. Thus, resistance of geyser is 209 ohm.
The benefits of electromagnetism are quite common in our day-to-day life. For example, electric doorbell, speaker, electric water pump, generator, radio, television antenna, loading and transporting scrap in a steel mill with the help of electromagnets. Substances in which magnetism is induced with the help of electricity are known as electromagnets, and the phenomenon is known as electromagnetism. Magnetic lines of force. The path along which the unit north pole or north pole of the magnetic needle moves in a magnetic field is called magnetic lines of force or magnetic field lines. Characteristic features of magnetic lines of force. 1. Magnetic lines of force are closed continuous curves starting from North Pole and ending on South Pole. 2. The direction of magnetic field at any point is given by the tangent at that point on the magnetic lines of force. 3. The magnetic lines of force never intersect each other. 4. The number of magnetic lines of force in a particular area denotes the strength of magnetic field at that place. That is, more the number of lines, more is the strength. Compass needle. Compass needle is a small bar magnet, the two ends of which point towards north and south respectively. The end pointing towards the north is called the north-seeking pole or north pole, and the end pointing towards the south is called the south pole or south-seeking pole. Danish physics professor Hans Christian Ørsted observed that when a strong electric current is passed through a wire, the compass needle gets deflected, showing the presence of a magnetic field. Definition of magnetic field. A field of force that exists in space around a magnet or a current-carrying conductor is called magnetic field. It is a vector, that is, it has a magnitude as well as direction. Its direction is given by the tangent to the magnetic lines of force. Magnetic field due to current-carrying conductor. In this activity, the sprinkled iron fillings on the cardboard get arranged in a particular pattern when an electric current is passed through the wire. This happens because of the presence of magnetic field produced due to passage of electric current in the wire. The flow of current causes deflection in the compass needle, which increases on increasing the magnitude of the current passing through the wire and decreases on increasing the distance between the compass and the wire. Thus, we conclude that magnitude of the field produced at a given point is directly proportional to the magnitude of the current passing through the wire. The strength of magnetic field produced by a given current in the wire decreases as the distance from the wire increases. Right hand thumb rule. If a person is holding a current-carrying straight conductor in his right hand such that the thumb points towards the direction of current, then the curled fingers around the conductor will give the direction of the magnetic field produced. Magnetic field due to current through a circular loop. The magnetic lines of force at every point of the loop in the given arrangement are in the form of concentric circles which get larger on moving away from the wire. At the center of the loop, these circles appear as straight line. The strength of magnetic field produced by a current carrying wire at a given point is directly proportional to the magnitude of current passing through it. If the coil has n turns, the field produced is n times stronger than the field produced by a single turn of the wire. This is so because each circular turn has same direction and the magnetic field produced by each one gets added up to form a much stronger field. Magnetic field due to current in a solenoid. Solenoid is a coil made by several turns of insulated copper wire wrapped in the shape of a cylinder. When a current is passed through the wire, the solenoid acts like a magnet with one end of the coil acting as the north pole and other one as the south pole. The field produced by it possesses all the properties of the field produced by a bar magnet. The magnetic lines of force due to current carrying solenoid are similar to those of a bar magnet. Solenoid can also be used to magnetize a piece of rod of a given material. If the rod is hard steel and if the field is strong enough, we can get permanent magnets. Rods of material like carbon steel, chromium steel, cobalt and tungsten steel can be used for making permanent magnets. Two alloys, nipper mag and alnico, are used for making permanent magnets in industry. Nipper mag is an alloy of iron, nickel, aluminium and titanium. Alnico is an alloy of aluminium, nickel, cobalt. Permanent magnets of such alloys are used in devices like ammeters, voltmeters, speedometers, microphones, loudspeakers, electric clocks, etc. Force on a current-carrying conductor in a magnetic field. In the given activity, a magnetic field is produced due to the electric current flowing through the conductor, which exerts force on the horseshoe magnet in the vicinity. French scientist André Marie Ampère, 1775 to 1836, suggested that an equal and opposite amount of force is exerted by the magnet on the current-carrying conductor. This force results in the displacement of the rod. The displacement is maximum when the direction of the current is at right angles to the direction of magnetic field.
Concept map. Potential difference is responsible for generation of current, which is represented by Q upon T. Current and potential difference are related by Ohm's law defining resistance. Current, potential difference, and resistance are used to calculate power, that is, rate of doing work, which is expressed in watts, and its commercial unit is kilowatt hour, that is equal to 3.6 into 10 raised to the power 6 joules. Resistances can be connected in series, which results in higher effective resistance, or in parallel, which results in lower effective resistance. Resistance has a property of resistivity. Resistance of a substance determines whether it is a conductor or an insulator. Heating effect of electric current is given by Joules law, which can be stated as I square RT upon 4.18 calories, or V square T upon 4.18 R calories, or VIT upon 4.18 calories. Heating effect of electric current has applications in daily life. For example, electric bulb, electric heater,